All right. Good morning, folks. This is the first lecture of week 9, which is to be delivered on July 12th, asynchronously. The problem that I'm going to be doing is called an ellipse generating mechanism. And in it, I want to bring up to your attention that there is something called a cylindrical joint. It's not a big deal. It's similar to prismatic. It's somewhere between somehow similar to prismatic joint or revolute joint. The difference is that for a prismatic joint, you basically need two lines or two axes and two planes to be coincident. Or in the case of revolute joint, it's the same story, two axes and two planes. In the case of a cylindrical joint, all we need is two lines to be coincident. For example, in this situation, if you look at the axis of this bar here and the axis of the hole and you make it coincident, it creates a cylindrical joint if you use the magic wand. Because this block can not only travel in that direction, it can also spin about that direction. Okay, so it has 2 degrees of freedom basically. But anyways, let's look at the problem that you want to do. I'm going to ignore totally the geometry, the dimensions and everything, and I'm just going to basically create a cartoon for you. So we have a base here with two blocks which can travel along these two paths, and there's this bar here with two pins, and the pins are inserted in the top of these two, two blocks. So as this block travels up and down this track, this bar will actually rotate, and when it rotates, the tip of it will actually traverse uh, an ellipse, and the size of the ellipse, so the geometry of the ellipse, had to do with basically this length and the position where the pins are located. So I'm going to totally ignore that and just go ahead and do the problem. All right. So here's a product. Immediately we're going to save it. File, save management, save as. Let me go one level up. We create a new folder here. It's called ellipse generator. And this is for the lecture on July 12th. Okay. All right. So let me insert the first part, which is the base. Insert a new part right there. And I'm going to call this thing the base. Right click properties, base, and base. Let's go make it. Double click on the base, try to make it. So on a convenient plane, on that horizontal plane, I will sketch. Why don't I make a centered rectangle to make my job easier, like that. Okay. And then exit, add it. Let me see now. Let me make it maybe 1 inch. Okay, good. Actually, to have an idea of how big these things are, let me go to my sketch and put a dimension there. I suspect that this is around maybe 5 inches. Make it 7 inches. And same thing here. Although actually the shape of that is irrelevant. The dimensions are irrelevant. All you need is two tracks on them. That's all. Exit. And remember, the palette height was height was 1 inch. So on that face, I will sketch. This is to create those tracks. Okay. So let me make a rectangle. Like so. I'm just going to put some dimension here so that I can remember what this thing is. I'll make it 0.5. 0.5. Okay. Exit. And I'm going to make a pocket all the way to the end, all the way to last. And since I am kind of lazy here, instead of making another one in the other direction, let me use this thing called circular pattern. Okay, two of them make a complete crown. A complete crown. No, hang in there. Okay, crown is good. Two, and I don't want the whole solid. I want this pocket instead, and for the actually what I wanted was this axial reference complete crown. That's what I wanted. That's what I wanted, not this tab. Okay, and the reference element is that face, and there we are. Oops, hang in there. How many did I make? Let's make it. I didn't really need. I didn't really need two, but okay, well, that's fine. Do it any way you want. If you can make this part, that's fine. I use the complete crown, and because I was just too lazy to do it. I mean, you can get this part the way you want it. That's fine. So you go up there, you save everything. Let's insert our block. Remember, there's going to be two blocks that go in these move in this passages. Okay, so I'm going to make that. So insert, and the two blocks are identical. So actually, I can use one of them, save it, and then use an instance of it, or just go ahead and make two of them. It's up to you. So new part, right-click properties. I'll call it block. If you don't want to follow what I'm doing, just go and make two blocks, please. Okay, let's go make it. On a convenient plane, for example, on that top plane sketch. Now remember, this thing was 0.5. I made it 0.5 because I wanted to have an idea of how big these things are. So I'm going to make it 0.5 by 0.5. Okay, so a zero point 0.5 here, a 0.5 there. Okay, and I'm going to make a hole, a circle there in the middle. Why don't I give some radius there? Actually, that's fine. I don't need a radius. I'm going to project that circle, whatever it happens to be. Exit. It's right. Where's the? Oh, it's right here, right there. I'm going to pad it by 1 inch. 1 inch. Okay, there. Now let's go all the way to the top. Save everything. And because I don't want to make another one of these, I'm going to say insert existing component in that folder right there. So that's the correct folder. See that? Ellipse generator mechanism. I saved it, so the block is sitting there. I'm going to say bring it in, insert existing component, and they're going to be sitting on top of each other. If you don't believe it, let's translate, for example, this guy up or this way, and this guy this way. You can see they're sitting on top of each other. They were sitting on top of each other. So there's two blocks. One is the instance of the other one. Fine. Now, we're going to do the rod. So we go all the way in the top, insert, new part, and I'm going to insert a new part in there. What happened here? Hang in there. Insert, new part. Oh, there. In there. It's done. So we're going to call it the rod properties, rod and rod. Excellent. Let's go make it. All right. So on this convenient plane, on that top plane, I will sketch. Why don't I project that circle? I think it is, I don't know, one of these. So project that circle is projected, and then we make the rest of it. So let me see. For the rod, I'm going to make a rectangle. Uh, a rectangle. Okay, something like this. We can always go and clean it up. All right, good. Now I want another circle over here. So why don't I, let's see now, why don't I make a circle? Let me see what the dimension of this thing is. I can't dimension it because this is projection, but 0.117. So I'm going to make another circle here. The radius of it is 0.117. 0.117, roughly the size of the other one. Exit. Now I want these pins to stick out of that, so why don't I do a multipath? So I'll do a multipath. You can make this thing any way you want. This is the big rod itself, so let's make this thing 0.2. And these are the little pins at the end. I'll make it 0.4 and 0.4. If it's too much of a hassle, just go make something like this. All right, good. So we go all the way to the top, save everything, and let's create our constraints. So first of all, we're going to anchor the base. That's anchored. So coincidence between, for example, this face and that face, and coincidence between this edge and this edge, that's going to become a prismatic joint. Update right there. And do the same thing with the other one going in that hole, in that other track. Where's the other one? Okay, coincidence between this face and that face. Okay, and coincidence between this edge and that edge. And update. Okay, don't worry, it's right. So we just translate this thing to in the x direction so that it ends up on that track. Good. So now we're going to put these pins inside of those guys. So coincidence between, for example, this axis and that axis, and coincidence between this plane and the top plane of that. And if the arrows don't point in the right direction, you flip it. Let me flip it and show you that actually that's probably what I need right there, okay? Now, this pin should go in that hole, but I don't have to make it plane to plane. All I need to do is axis to axis because of the way this is constructed. So this is going to be revolute, but this one is going to be prismatic. I mean, so what? So this axis and that axis. Okay, and update. And there we are. Okay, good. Let's check, see if it's working. So we click on the move, on the manipulate, check the box here with respect to the constraint, and rotate, for example, rotate this about that axis. Oops. Okay, look. It is doing what it's supposed to, okay? So we say okay. Now we're going to go to the, well, first of all, make sure you save it in case there's a power outage. So then we're going to go to digital markup, DMU kinematics, get the magic wand out. Where's the magic wand? Oh, right here. A new mechanism, Okay. Auto create, there will be two prismatic joint for the blocks, one revolute joint for this end, and one cylindrical joint for this. So let's check it out. On the, we don't need these things anymore. Mechanism, obviously degree of freedom is 1. Two prismatic, one revolute, one cylindrical. Okay, very good. Degree of freedom 1, and I can, to animate, I have to remove this. So I can make that revolute joint, for example, angle driven. So let's go to that revolute joint, make it angle driven, going between 0 and 360. Mechanism can be simulated. You can try it manually. There's going to be a single sliding bar because this was a single degree of freedom system, and we removed that 1 degree of freedom system by specifying the angle. Now you can create a cartoon. You need this mechanism because I want to get the trace, and that simulation has to be compiled. So we drag this thing, insert, rewind, anything but 1, and you can play it continuously, so it goes like this. So a simulation has been created. It's at the bottom of your tree. You can see that. We say stop, rewind, OK. Now we're going to compile it. So we go to the same place that you created the simulation, expand the choices, and you see that there's a compile here, right there, compile simulation. And I just want to generate a replay. I don't want to create a video clip. Otherwise, I do this checkbox and put the JPEG or the MP4, MP3, whatever, in the right spot. But anyway, I don't want this. I choose anything but 1, anything but 1. And you say, OK, wait for it to go. Good. And now you're going to go and do the trace. Without this replay, you cannot do the trace. You click on it, trace. It says element to trace is that point, okay? And reference product is product 1. I don't know, still cannot change this thing. I don't understand why, but anyway, so just leave it the way it is. So we say okay, just be patient. There we are. Let's save this because on the test I might ask you to generate a trace, save it, and bring it into the mechanism actually. So so you need to file, save management. Everything was already saved except for this trace. You can see that there's nothing there. Save as, you can give it any name that you want. It's in the correct folder, ellipse generator mechanism. So I'm going to check to see whether you generated it or not. And then once I see that you generated, I'm going to say insert. I mean, you have to do that, not me. Insert existing component in that product. And which one is it? It's that trace, right? It's this one that you just saved. And there we are. So as this thing, as you play, as you do the replay, you can see that this point actually traverses that ellipse. It is an ellipse, by the way. So let me do it continuously. There we are. Okay, that takes care of this problem. There is no physics here, but you can specify, for example, you can specify the angular velocity. Maybe this revolute joint, there was a motor, stepper motor sitting here, or a continuously rotating motor with a given RPM. Then you should be able to find out what is the velocity, for example, of this point or some other point. So you have to create a formula, put some physics into it, create a sensor, and generate the graph that I want, and then print screen, save it in a Word document with the name that you either you're asked to or you want, and put that Word document in the folder that you just created, and everything else is in there. And that takes care of this lecture.